Hello class, we're doing section 4.2 now, and 4.2 is an introduction to logarithms. So first we're going to talk about the definition of a logarithm, and then we'll talk about how it's the inverse of exponential functions. But right now we're just going to work through our handout. There is our new notation for a logarithm, and what we say is the log base b of x equals y. Logarithm is a function. And remember, a function does something to a number. If you were just to see something like this, a log base b without any x next to it, or just a log without anything next to it, that wouldn't make any sense. The log acts on a number. It's a function. It does something to a number. Kind of like square root. You know, just seeing a random square root symbol doesn't make any sense. Okay, so what does this new notation mean? Well, I think the easiest way to understand it is to rewrite it in exponential form. And this is the definition of a logarithm. And I always say it this way. I've got a base of b. What exponent did I put on b, that would be y, in order to get an answer of x? Okay, so log base b of x is asking you, you've got a base of b, you put the exponent of y on b in order to get your answer of x. And the first several problems are just about going back and forth between log notation and exponential notation. Okay, so number one, our base is 2. The exponent we're putting on 2 is 3, and that will equal 8. And is that true? 2 to the third equals 8? Yep, it is. Okay. Number 2, our base is b. Oh, we don't know what the base is this time. The exponent is 4, so b to the fourth is equal to 256. And now if you just did some guessing and checking, you could figure out what b was, probably with just a few guesses. Or you could take the fourth root of both sides and solve this equation to figure out what b is. I'll let you guys do that. Number 3, let's do it one more time. I've got a base of 5. X is the mystery exponent. What exponent do I put on 5 to get an answer of 125? And this one you have to do by just thinking about it. What exponent could you put on 5 to get an answer of 125? Well, how about 3? 5 to the third is 125, right? Okay, so that's the thought process we want to go through. Okay, now let's go the other way. So we're given an exponential equation, and what we want is we want to write it in logarithmic form. So I start with the log. The base is a subscript. Okay, so what's the base? 3. Of what? 1/9, and I'm going to put it in parentheses just to emphasize that that's a function, equals the exponent, which is -2. Okay, let's try it again. Log. Base is 4. Of what? Well, if you always remember that the log equals the exponent, another way of saying that, if you can use an equal sign, it means a log is an exponent just in a fancy form. Then what's left over is what you're taking the log of. So the log base 4 of x equals 2. Okay, let's do this one, number 6. Okay, now the first thing on number 6 is we can't use radical notation when we're doing logs. So we first have to change this to something that has an exponent. So remember, 64, remember the third root is the same as the 1/3 power. So 64 to the 1/3 power equals 4. Okay, that's true. Now, log base 64 of 4 equals 1/3. Okay, so go back through those. Those are just your practice problems of going back and forth between exponentials and logs. Okay, now, that's interesting. Okay, now we're just going to try and evaluate some expressions. I left space for basic properties, but we're going to come back to that. We're going to try and figure out what these basic properties are. Okay, first, every time I see a log expression and it says evaluate, evaluate means find the answer, find a numerical answer. So I ask myself the question, if I have a base of 10, what exponent did I put on 10 to get an answer of the square root of 10? What exponent did I put on 10 to get an answer of the square root of 10? Well, that exponent must be 1/2, because we know 1/2 exponent means the square root. Okay, let's try the next one. If I have a base of 3, what exponent did I put on 3 to get an answer of 1/27? Okay, so first you need to go back and review your exponent rules. You have to feel really comfortable about exponents, because when I look at this, the only way to do this is by inspection. You look at this and you say, well, 1/27 is a reciprocal, or it's a fraction. So I know x must be a negative exponent, because that's what negative exponents do. They flip things over, right? And then I say, well, 3 to the what is 27? Well, 3 to the third is 27. So if x is -3, now plug it back in and check. 3 to the -3 is, in fact, 1/27. Okay, let's do a couple more. Let's see. Number 9. If I have a base of 25, what exponent did I put on 25 to get 5? Well, what did I do to 25 to get 5? I took the square root. So my exponent must be 1/2. Okay. All right, let's do it again. This time I have a base of 7. What exponent did I put on 7 to get an answer of 1/7? Well, first, I see it's a fraction, so I know my exponent must be negative. And second, I see it's the square root of 7, and I know 1/2 exponent is the same as square root. Okay, let's do another one. If I have a base of 4, what exponent did I put on 4 to get an answer of 1? Well, the only way you can get an answer of 1 from an exponential expression is anything to the 0 power is 1. Remember that? That's a definition. That's because I said so. Anything to the 0 power is 1, so x is 0. Okay? Now that leads us to our first basic property, which I'm going to write on a separate piece of paper here for you. So, basic log properties. Oops. So the first one is, if you have the log of any base of 1, log any legal base of 1, that will always equal 0. Because, and this is not part of the rule, I just want you to understand it, if I have a base of b and I put an exponent of 0 on it, I will get 1 every time that we have a base. And remember, this is a base that's only allowed in the logs, which we talked about in class. There's rules for the bases. Okay? All right, let's try another one. Number 12. If I have a base of 7, what exponent did I put on 7 to get 7? Now that just seems silly, but the answer is clearly 1, which is the next basic log property. Log base b of b is always 1. Okay, now I'm going to pause. We're going to need to do this in a second part.